system of equations is where you have more than one equation and more than one variable. So in this case, we have an x and a y. When you have two variables, you have to have two equations in order to solve them. If you have three variables, you have to have three equations, and so forth. As you get into Algebra 2 and Algebra 3 or Pre-Calc, you'll have multi-variable systems where you'll have to solve them, more than just two. One way to work the problem is by elimination, where you try to line up the variables in the equal signs and you try to eliminate a variable. How many people did this one by elimination? Okay. The other way to work the problem is by substitution. Substitution is where you try to take one of the equations and get x by itself or get y by itself. And then whatever it's equal to, you substitute that into the other equation for that variable and solve. Anybody in here do substitution? Okay. All right. And so it doesn't matter which way you work the problem. I'm going to start with the elimination method, review that real quick. So those of you that did elimination, which equation, number 1 or number 2, did you multiply by a number? Okay. So Ann multiplied both of them. Did anybody not multiply both of them? Okay. What did you guys multiply? Okay. So just the bottom one, okay, by -2 because you eliminated which variable? Y. And you multiplied the top by 5 and the bottom by 2 because you eliminated x. Okay. And so either way is fine. I'm going to go ahead and eliminate the y. It'll be a little faster, but either way is fine. So I'm going to multiply the second equation through by -2. Why did you do a negative? Very good. When you do elimination, you have to have one variable positive and one variable negative so that when you add them, they cancel out. So I'm going to rewrite this. I'm numbering my equations. When you take Algebra 2, Mrs. Siegert's going to encourage you to, or require one of the two to number your equations so you can follow your work, especially as you get more than two equations. It gets a little bit tricky. So I'm going to rewrite this. 2x plus 4y equals 72. And then I'm going to multiply and distribute this -2 times everything. So you ended up with -10x minus 4y equals -216. All right. And then we add straight down in the elimination method. So 2 minus 10 is -8x. 4 minus 4 goes away. That's eliminating. And then -216 plus positive 72 ends up giving me -144. Is that correct? Yep. Divide by a -8. And x is equal to 18. Did you get 18 as well, Ann? Okay. Anybody not get 18 who worked it by elimination method? Okay. You found your mistake? Okay. Anybody not find their mistake, though, and do it by elimination? Okay. Once you find out what x is, then you can go back and plug it in anywhere. You can go back into the original equations or the new equations. It doesn't matter. Substitute it in and solve for y. So I'm going to go back to equation number 1 here. 2x plus 4y equals 72. 2 times 18 plus 4y equals 72. 36 plus 4y equals 72. Subtract 36. 4y equals 36. And divide by 4, and y is 9. And so the question or direction said solve the system. And so the system would be x equals 18 and y equals 9. And remember that that means if you were to graph the two lines, 18, 9 is where they would intersect. That's their point of intersection. Okay? 216 minus 72. 6 minus 2 is 4. 21 minus 7 is 14. Does that make sense? Okay. Any other questions? Okay, I'm going to show you what I did just because I think it made my numbers a little smaller. Just a heads up, something you could do is I took equation number 1 and I noticed they were all even. So I just divided them all by 2 to make those numbers smaller, which also would give me the same number in front of the y. So I divided everything through by 2 and got x plus 2y equals 36. You can do that as well. But then I would need to multiply one of these through by a negative. So I chose to multiply the bottom one through by a negative. negative 5x minus 2y equals negative 108. Just made my numbers a little smaller to work with. Gave me negative 4x, those canceled, equals, and this was negative 62, no, about negative 72. And then divide by a negative 4, and x was equal to 18. So just another option for elimination. Because I'm just looking at each equation separately. Whatever you do to one side of an equation, not every equation, you have to do to the other side. So all I was doing was just simplifying this. Nope. No, because I'm doing it to both sides of the equation. If I were doing it to just one side, I would have to factor out the 2 and keep it. But because I'm multiplying both sides by a half or dividing by 2 instead. Okay? Substitution. Those of you who did substitution, hands up one more time. Just Daisy and Harry. Okay. So if I do substitution method, on that one, Daisy, what did you solve for? Which equation and what variable? Okay, so the top one you solve for x. Okay, so by substitution, if you have 2x plus 4y, what's it again, equals 72. So we're looking at the very first equation. To solve for x, I would need to subtract the 4y. And then I would need to divide everything through by 2. So x is equal to negative 2y plus 36. And then I would take all of that, everything that x is equal to, and I would substitute it back in to the second equation where the x is. So I would have in the second equation 5 times, and now I'm going to plug in negative 2y plus 36 plus 2y equals 108. So substitution method, you're just solving for one variable, plugging it into the other equation where that variable was. And then you distribute. So we get negative 10y plus 5 times 36 is 180 plus 2y equals 108. Negative 10y plus 2y is negative 8y plus 108 equals 108. Did I do, or sorry, that's how about 180. Little dyslexic there today. Subtract the 180. And so we have negative 8y equals negative 72. Divide by negative 8, and y is equal to positive 9. And then again, you can plug it back in anywhere. I would plug it always back into where you had first solved for the variable, because that's what you're looking for is x anyway. But you can plug it back into any equation. Coming back to you, substitution and elimination. Any questions? And you can pick any equation and solve for any variable if you're going to do substitution. The one thing you want to be careful about, though, is if, for example, I were going to choose equation 2 and solve for x, if I divide by 5, I'm going to end up with some ugly fractions. So you always want to try to solve for a variable that either has a 1 coefficient in front of it, or where when you solve for it, you don't end up with fractions. All right, if you need extra help, though, with solving systems, sign up for Encore, come in, and I'll help you, okay? All right, I'm going to pause this for a few minutes, and I'm going to pass back the tests. But the first section, you'll notice, is just one page front and back. It's pretty easy, and part of it you actually should have discovered on your homework last night. So on the core math page, when they gave you this picture, I'm just going to number these angles, whatever. I don't know what they were on the picture exactly. But they asked you what was true about these two angles here and these two angles here. What did you find out about them? Okay, they are same side interior, but we learned that last class period. What did you figure out on the notes, though, about the sum of these two angles? Okay, they were supplementary and they equal 180. What did you find out about angles 1 and 5? Okay, they are corresponding, but what about their measurements? Okay, they're congruent. And so what this whole lesson in 3-2 is about is Those things that you figured out on the core math page are only true if the lines are parallel. So be careful, because just because they give you two lines cut by a transversal, the sum of the interior angles here are not always going to be 180 degrees. It's only true if the lines are parallel. These two angles are only going to be congruent if the lines are parallel, not if they're not parallel. Okay? So the first thing that we're going to do in section, vertical angles, yes, they have nothing to do with lines being parallel. So vertical angles are always congruent. That's why we have that theorem. So the first section here, 3.2, is going to basically give us some theorems or rules about the different 5 angles that we talked about the other day: corresponding alternate interior and exterior, and sunside interior and exterior. But everything we're learning today only works if the lines are what? Parallel. So it's very important that, I don't need this section, I don't know why I'm on 31. So sorry. Let's delete that. I don't know off the top of my head. I'll have to check that in a little bit. Usually they get smaller, so I think so. Okay. So, back up here, guys. Hey, guys, seriously, we don't have enough time to get through 2 sections, okay? So make sure you're with me up here. Has to be parallel today, though. Okay? Has to be parallel lines. If they're not parallel, this is not true. I want to emphasize that a bunch so that you don't make a mistake on the test or homework. All of these angles have those names. So these will always be corresponding, but they're just not always congruent. Only if the lines are parallel. Okay, so we're looking at some theorems, and they're not very easy to read in your notes. So just so you know, they are in your textbook. All these charts that are in your notes are also in your book. So if you can't read that fine little tiny print, just look in your textbook in section 3.2. So the very first theorem is called the corresponding angles postulate. Remind me, what's the difference between a postulate and a theorem? Okay, postulates are accepted as true, but they have not been proven true. So the reason why they're going to call this the corresponding angles postulate is because we're going to believe this is true. We're going to accept it that it's true without having proven it true. But then we could use this one postulate for all the other ones we're going to learn, and we could prove those true. So they're all going to be theorems. This is the only one that's going to be a postulate. Corresponding angles postulate. And it simply says what you discovered in your core math page, that if you have parallel lines cut by a transversal, then the corresponding angles will be congruent. Always. If the lines are parallel, the corresponding angles will be congruent. So then they remind you what angles are corresponding over here. Okay? The next one, oops, this is important here. If a transversal is perpendicular to 2 parallel lines, what's it mean if it's perpendicular? Okay, it creates right angles. So if I have a transversal and these lines are parallel, notice the little extra parallel marks, then if this is perpendicular to both of the lines, use what we now know. Vertical angles are congruent, so what's going to be true about this angle? Right angle. This is vertical, so it's going to be a right angle. These are a linear pair, so this is going to be a right angle. And eventually we worked our way around and we have how many right angles? 8 right angles. How many different measurements do we have? 1 measurement. They're all 90, right? Let me go back here. How many different measurements do we have in this picture? For example, let me say this is 150. What's this angle measure? 30. So how many different angle measures would we have throughout this picture? 2. Is everybody clear on that? So you'll only have 2 angle measures if the lines are parallel. Notice those little marks. If the lines are parallel, you'll only have 2 different measurements, but you have 8 angles. It didn't, because that last section was trying to get you to discover some relationships without knowing the lines were parallel. So when you discovered those relationships by proving it with different information, then what it leads to is, since that was true, these lines had to have been parallel. Okay? But they did not tell you that they were parallel last time. Okay, but if they are parallel, you'll have only two measurements because all of those angles will match up either vertically or correspondingly. But if the lines are perpendicular, you'll only have one angle measurement. You still have the 8 angles. The parallel lines, you mean? If they're parallel, but if they're not, then they won't be there. So you can only know for sure they're parallel if the lines are there. So always look for that. Correct. Correct. Just perpendicular means makes a right angle. So if they tell you that a transversal is perpendicular to both parallel lines, then that means all 8 angles are going to be the same measure. They're all going to be 90 degrees. All right. I'm going to skip that slide. It's not important. This is the one that's hard to read. So again, this is in your textbook. I'm going to ask you to add on this page same side exterior angle theorem, because again, this book leaves that out every time. I don't know why, but they do. So here's some things to point out. First of all, alternate interior angles theorem basically says if you have parallel lines, so again today, everything is about whether or not the lines are marked parallel. If you have parallel lines, what's going to be true about the alternate interior angles? They're equivalent. They are congruent. Alternate exterior angles theorem is going to say if you have parallel lines, what's going to be true about the alternate exterior angles? They're going to be congruent. So right now, I want us to make just a quick little chart in our notes about all the angles that we know are congruent and which ones require the lines to be parallel. So congruent angles. One angle pair that we know are congruent. Tell me what's one angle pair. Okay. Alternate interior angles. What other kinds of angles are congruent? Alternate exterior angles. What else? What's the first one we talked about today? Corresponding angles. Okay, what other kind of angles before today did we know are always congruent? Vertical angles. 3 of these require that the lines are parallel. One of them does not require lines being parallel. Which one does not require the lines being parallel? Vertical. Vertical angles have nothing to do with parallel lines. Lines could be parallel, they don't have to be parallel, but vertical angles are just across from 2 intersecting lines. So you might have some lines cut by a transversal. The vertical ones are still going to be congruent. Okay? Doesn't matter if these 2 lines are parallel or not. Corresponding alternate interior and alternate exterior, they are only congruent if the lines are parallel. If they don't tell you the lines are parallel, you do not know that the angles are congruent. Okay, the next 2 theorems are about the same side interior and same side exterior angles. And that's the thing you discovered on that core math page. You discovered that the same side interior angles were what? They equaled 180, so they were supplementary. That's what this theorem says. It says if the lines are parallel, so again it requires that you know the lines are parallel, but if they're parallel, then those angles will be supplementary. Here's how I remember that. SSS. If it starts with same side, they're going to be supplementary. If it doesn't start with same side, they're going to be congruent. So same side supplementary. SSS. So my supplementary angles, make a little chart here for those. I know for sure right now that at the same side interior angles are going to be supplementary. They're going to add to be 180. If we think about that, so we know that if this is 150, this is 30. We know this is 30 because it's vertical. We know this is 150 because it's a linear pair. So this is 150 because it is vertical. We know this one's going to be 30 because they're same side interior. This is going to be vertical, so it's 30. These are a linear pair, so it's 150. So what do we notice now about the same side exterior angles? Or excuse me, I just circled alternate. Teach correctly, Lashley. What do we notice about the same side exterior angles? They're supplementary also, SSS, same side supplementary. I'm not going to write out this whole theorem. It's going to say the exact same thing as this one does here. If two parallel lines are cut by a transversal, then the two pairs of same side exterior angles are going to be supplementary. Okay, so it's going to say the same thing. So I'm going to add that here. Go ahead, Kaya. So these angles are always going to be supplementary as long as the lines are parallel. So this requires the lines to be parallel. Two lines are parallel. So like say I had a picture here, and they told me that this was 150 and this was 150. Is that what you're asking? Like, what kind of angles are they? Or, so those would be corresponding angles because of their location. They're congruent. Corresponding are on the same side, but they're not interior. Interior are all of the angles that are in between the two lines. Exterior are all the angles that are outside the two lines. So if these are my two lines, these are exterior angles, these are exterior angles. Exactly. They're on the same side, one's inside, one's outside. Okay, so everybody with me that now all of our same sides are supplementary if the lines are parallel? What other kinds of angles were supplementary but have nothing to do with lines being parallel? Very good, Emily. Linear pairs. So if you see a linear pair in a picture, it's always going to be supplementary. It has nothing to do if the lines are parallel. Linear pair are two angles that are side by side and form a straight line. So that would be an example of a linear pair. Okay, so this lesson is going to be revolving around these 5 theorems. One's a postulate, the other 4 are theorems. Corresponding angles, postulate, everything else is a theorem. And all they're going to ask you to do is take a picture and start trying to figure out the angle measurements. Now, my best advice to you is not to look at the picture and only look at the angles that they're referring to. Remember, if they give you one angle or 2 angles, you can probably fill in the entire picture with all of the angles, right? So it might be easier to just kind of work your way around the picture until you get to what you're looking for. But the very first thing you're going to make sure about is that the lines are marked parallel before you do that. Okay, so find each angle measure. We want to find ECF. So ECF, we're looking for this angle right here. It's what? 70. How did you know it was 70? Okay, so on your homework, I'm going to make you be very specific, okay? And I'm going to be very picky because the next section we're getting ready to do is going to include proofs. So in this section, I want you to explain how you know, and when you explain, I want you to use the postulate or the theorem name, okay? So ECF would be 70 degrees. And if the directions say, name the postulate or theorem, or tell me what kind of angles they are, then you name it correctly. So this would be 70 because of the corresponding angles postulate. These 2 angles are corresponding, and because the lines are parallel, that means they are congruent. That's what the postulate says. If the 2 lines are parallel, corresponding angles are congruent. So this would be 70 degrees. Everybody okay with that? Postulate is accepted as true. Theorems are proven true. Okay, could I find every other angle measure in this picture just by using this 70? Hold on, Claudia. What would be the measure of this angle? 110, because these 2 angles are what kind of angles? Linear pair. So you would say linear pair theorem if I asked you how you knew that was 110. If this is 110, what's this angle right here? 110. What kind of angles are these angles? Vertical. So you would put vertical angle theorem if you told me why. Okay? What would be the measure of this angle? Here. 110. How do you know that? Okay? Could be two different answers. You could say corresponding angles postulate, or you know this is 110 already. What kind of angles are these? So you could say alternate interior angles theorem. So if I were grading your homework and you told me 110, I would accept either one of those answers as correct. Either corresponding angles postulate or alternate interior angles theorem. Question 5. So here would be my answer to I think where you're headed. Could you have had a different answer for why this was 70 here to start with? If you did it that way, you would have to list every single theorem that you used to get there. So yes, you could have said vertical angle theorem to get this measure, then linear pair theorem to get this measure. Then you could have said corresponding angle theorem to get this one, and then linear pair theorem again to get this one. And that would be fine, but you would have to list all of those steps unless you just use one theorem. Okay, so just make sure you list everything. Okay, so DCE is the next question. DCE. So we already know what the measure of that angle is. What is it? 110. Did we use 5x at all? No. You could have worked it differently. You could have said 5x plus 70 has to equal 180 using that linear pair theorem, and then solved for x and then plugged it back in. Try not to make things harder than they have to be. It's very easy to find that that's 110 degrees without doing all of that work. And it never said solve for x. So we don't even have to know what x is. Is that okay? All right. Oh, and then, yeah, let me list what I did. We knew this was 70 by using the corresponding angles postulate up here. So now what theorem did I use to get that this was 110? Linear pair. So linear pair theorem. And make sure you're including that word theorem or postulate where appropriate, because that's going to help us for proofs. Okay, next one, find QRS. Again, the lines are marked parallel. So what is QRS going to be? Say it again. 62. Very good. Now, Harry, what theorem or postulate did you use? If you used corresponding, that wouldn't be good enough. That would tell me this is 118. So then what else did you use? Okay, so if you didn't use corresponding, you could have just said these two are supplementary. So 180 minus 118 is 62 degrees. And that would be using one theorem. And what was the theorem, Harry? Same side, interior angle theorem. So just make sure you're backing up whatever work you're showing correctly. If I used corresponding angle theorem, then I would have to use what theorem to get that this one's 62? Linear pair theorem, because these two together would be 180. Not on your homework or on the test. In your notes, you can do whatever you want. Any other questions? Okay, we'll do the next one. They have to be adjacent and they have to form a straight line. So there's no other way they could be sideways, but they have to form a straight line and they have to be adjacent. Oh, so it could look like this, but those are still adjacent and form a straight line. Any measurements as long as they're adjacent and form a straight line. Oh, yeah? It's given to you in your notes what they're called. And then you just have to know, based off what they're called, what to write. So the corresponding angles is a postulate. That's what it was titled in your notes. We're going to accept that one as true, and then we're going to use it later in the notes to prove some of the other ones true. So everything else is going to be a theorem in today's lesson. So it's alternate interior angles theorem, same side interior angles theorem. So corresponding is the only one that's a postulate. Vertical angles was a theorem. Linear pair was a theorem. If you look back in your notes or in the back of the book, it'll list what they're called. Yesterday we didn't have any postulates or theorem. Yesterday was just naming the kinds of angles that are formed when two lines are cut by a transversal. So there were no postulates or theorems at all. Today's the first day that we're looking at postulates or theorems for these 5 angles. We had all 5 angles yesterday. No, that's just the name of the angle. So if I were to draw you a picture and say, what are these angles? You would tell me they are corresponding angles, period. No postulate or theorem. The postulate or the theorem is written in if-then form. If these 2 lines are parallel and cut by a transversal, then these 2 angles, which are corresponding, will be congruent. That's what the postulate says. The name corresponding is just naming what kind of angles they are. Okay. For this picture, we want to find EDG. EDG. Alright, so Harry's on top of it. Somebody over here. What's the measure of EDG? What is it? 75. Did you have to do any work at all to find that? No. Why? What theorem or postulate did you use? Good. Look for the one that gave you the angle measure, 75, and that means because these 2 angles are alternate exterior, that they are congruent by the alternate exterior angles theorem. With no work. Now, and I'm abbreviating up here on the board, but do not abbreviate on your homework. They will have some where you do have to do work, okay? But in this case, I didn't have to do anything. I could just simply say they're equal. All right, how about BDG? BDG. What's this angle? 105. How did you get that? Very good, Emily. These 2 angles are adjacent and form a linear pair. So that means this angle is 105 degrees by the linear pair theorem. Could we solve for x now? Or do we know what x is? Yeah, x is 105. Could we have solved for x here? Yeah, we could have said x minus 30 equals 75 and then added 30 and got 105. So if they ask us for x, we could find it, but we don't really have to use any of those expressions if we just look for the actual measurement on the picture. Here. All right, let's look at one where we do have to do some solving. So this one wants us to find ABD. So we're looking for this angle right here. They don't give us anything in the picture with an actual degree measurement. But we do have 2 angles. It's kind of hard to tell here, so when you're looking at your homework, whatever it's closest to. This angle is closest to here. This one's closest to here, so they're talking about this angle and this angle. What kind of angles are those? Okay, and so the alternate interior angle theorem says what's true about them? They're congruent. So 2x plus 10 should equal 3x minus 15. Solve for x. Subtract 2x. So 10 equals x minus 15. Add 15, and what is x? 25. Is that our answer? No, because it didn't ask for x. What did it ask for? ABD. So we have to plug that back in. Measure of angle ABD equals 2 times 25 plus 10, which gives us what? 60. 50 plus 10 is 60, and don't forget your degree symbol. Don't forget to use your little M for measure. Any questions? Okay, next one gets a little harder. So in this diagram, you've got 3 lines, and they are all marked parallel to each other. And then you have 2 transversals, but they are not marked parallel to each other. Be very careful. P and Q are not parallel. L, M, and N are. Okay? They want you to figure out what X and Y are in the diagram. So first of all, I need an equation that I could set up to solve. Does anybody see a relationship where we could write an equation down? Corresponding, give me the equation first, and then we can talk about it. I don't know, so I'm asking you. Tell me, what would you equal? What equation? What would you write down? Okay, be careful. First of all, this angle that it's pointing to here and this angle that it's pointing to here are requiring P and Q. Those are corresponding angles, but they are not congruent unless the lines are parallel. And P and Q are not marked parallel, so these two are not congruent to each other. Okay? So I need a different equation I could write down. And okay, are you guys with me? This is what it's going to be like on your homework, so this is important that you are understanding here. What do you see as a relationship looking at your parallel lines, any parallel lines, and a transversal? So what would be the equation I would write down? Okay, so you're saying this angle and this angle. What kind of angles are those? Say it again. Corresponding. And when I look at this line and this line and this line, which make those two angles, these are the lines that are cut by this transversal. So since these are parallel, then these corresponding angles are what? The same or congruent. So you are correct, Rachel, that I could write down 5x plus 5y equals 60. What's wrong with that equation? Why can't I solve it? Because I have two variables. So we just reviewed at the beginning of class, to solve an equation with two variables, you need how many equations? Two. So now I have to go back to the picture, and I have to find another equation I could write down. Oh, yeah? Okay, so when I'm looking at this angle and this angle, they are formed by this line, and this transversal. When you get to the homework, you may have to redraw the picture and only darken or mark the ones that you're actually using. I'm not using this green line in the middle at all, so I'm going to ignore it for right now. These two lines and this transversal P make these two angles. What kind of angles are they? Alternate interior. And if the lines are parallel, alternate interior angles are what? Congruent. So since they're congruent, we can write down 5x plus 4y equals 55. You will have questions on your homework and on the test like this problem right here. So it's very important that you know how to do it. Okay, we have a system of equations. Do you want to do substitution or elimination? Elimination, I like it as well. Do you want to eliminate the x's or the y's? X's. So we need to multiply. I'm going to do the top one by what? -1. So I'm going to rewrite it down here. After I multiply it by -1, gives me -5x minus 5y equals -60. Now I'm going to add these two equations. So my x's cancel. And what do I end up with? Add straight down. -y equals -5. So we need to divide by -1. And what do we end up with? Y equals 5. It said find x and y. So y is 5. And now we can plug that back into any of those three equations. Does not matter. I'm going to go back to the very first equation up here at the top before we multiply by -1. So 5x plus 5 times 5 equals 60. So 5x right here. Could you do substitution, or did I? You can, as long as you make sure. The reason I don't teach it that way is because what happens in my past career of teaching students is they'll do 5 minus 4 and they'll forget to do 60 minus 55 and they'll add. So I always teach it as get the variable to have the same number, one positive and one negative, and add straight down so that they don't forget to subtract everything. But it's totally fine if you just want to subtract at the very beginning. Since you have the same number, you're just subtracting each term. Perfectly fine. Here, those are corresponding angles, so corresponding angles postulate. Two lines cut by a transversal that correspond. And then the other one we used was the alternate interior angle theorem. These two red lines cut by this transversal, these are alternate interior. Okay. So here I have 5x plus 25 equals 60. Subtract 25. 5x equals 35, and so x is what? 7. This time it just said find x and y, so you're done once you have this. We're not finding the angle measure, so no, we're just finding the value of the variable. And I'm worried about you over there. Heads up, take notes with me, okay? It's not asking you to find the solution to a system. That's when you write it as an ordered pair. This is just saying what is x, what is y. Okay? It's not, I guess, technically wrong, but it's not asking you for a point. Writing it as an ordered pair is telling me a point. Okay? All right, any questions on this first section 3-2? Okay, so big idea one more time. We have 5 new ideas. One's a postulate, the other 4 are theorems, and they're all only true if the two lines are what? Parallel. And in your picture, you have 4 types of angles that could be congruent and 3 types of angles that could be supplementary. And you're either setting them equal or adding them and setting them equal to 180. Okay? All right, so look at 3-3. And 3-3 is basically going to go backwards. It's going to be the converses. Everything we just did. What's a converse do? Switches what? Yes, it switches and says Q implies P, so it switches the hypothesis and switches the conclusion. So here's what this section is going to do. It's going to, instead of, so look back at your theorems from the ones you had in 3-2. Instead of saying, if the 2 parallel lines are cut by a transversal, then corresponding angles are congruent, it's going to switch it. And it's going to say, if two lines, and it's not going to say they're parallel. It's going to say if 2 lines are cut by a transversal so that the corresponding angles are congruent, then the 2 lines are parallel. So it's just going to switch. It's going to allow us to prove that lines are parallel. That's going to be our goal in this section. Write a proof to prove that lines are parallel. And you're going to have 5 ways that you can prove them parallel. If corresponding angles are congruent, the lines must be parallel. If alternate interior angles are congruent, the lines must be parallel. If alternate exterior angles are congruent, the lines must be parallel. Or if same side interior angles are supplementary, then the lines must be parallel. Or if same side exterior angles are supplementary, then the lines must be parallel. So it's going to switch them. It's going to be the converse. And so every name is now going to have the converse at the end of it or at the beginning. So you're going to have 5 theorems in your notes, and they're all going to say corresponding angles postulate, but the beginning is converse of the corresponding angles postulate. The next one's going to say converse of the alternate interior angles theorem. Okay? I got in a bad habit years ago of writing it as corresponding angles converse. So when I write my answers, I usually write it this way, corresponding angles converse. If you do that, that's fine with me. I'm not going to count off. If you write converse of the corresponding angles postulate, that's totally fine too. Okay? So I'll end up doing that a lot. Okay, so all of them are going to start with if two coplanar lines. It's not going to say parallel because what you're trying to prove is that the lines are parallel. Okay, so in a proof, if you had a picture and you had that the corresponding angles were congruent, so this would be statement 1, then you could say line M and line N must be parallel, and you'll see them write it like this a lot. They won't write the word line. They'll just put M parallel to N, and they'll use the little lowercase letters, and that is good notation. Okay? You can say that the lines are parallel, and this would be your reason. It would be the corresponding angles converse. Okay? And then here's all of the other ones, and they all say the same thing, they're just switched. So two lines, not parallel. If the alternate interior angles are congruent, then the lines are parallel. Converse of alternate exterior is going to say two lines, not parallel. If the alternate exterior angles are congruent, the lines are parallel. And then same side, this one's different because it's going to say that the same side angles have to be supplementary, and that means the lines are parallel. And then we're missing one, so in your notes, add the last one. Same, oops, let me write it this way. Converse of same side exterior angles theorem. And it's going to say the same thing as the converse of the same side interiors. That if the two lines are cut by a transversal so that the same side exterior angles are supplementary, then the two lines must be parallel. What word has to be on the theorem in order for it to prove lines parallel? Converse. When you're giving me an answer and you're trying to back up why lines are parallel, your reason has to have converse. Okay, that's the thing that a lot of students make a mistake with, is they leave off the converse and then it's wrong. So let's look at some examples. These are all going to be proofs for the most part, okay? They're going to say, show. When you see that show, I want you to think proof. And we're going to do a two-column proof. Some of them are going to be so simple, they're just 2 steps, and you're going to think, well, that's stupid. And then some of them are going to take more steps, okay? So, and some of them even tell you exactly what to do, like this one. Use the converse of the corresponding angles postulate. So they're telling you what to use for your proof. They want you to prove that L is parallel to M, and you are given that 4 is congruent to 8. Okay, so you're going to write a little 2-column proof here. Write out your word statement and reason. Statements and reasons. Number 1, what are we writing down for the given? Good. 4 is congruent to 8. So angle 4 is congruent to angle 8. And what's the reason? Given. What are we trying to prove? Are you with me? Hold on just 1 second, Emily. It says use the given information to show that L is parallel to M, and then down here is where they're giving us the given information. If the directions tell you to show, then on the homework that means write a proof. Okay, so we are writing a proof to prove that L is parallel to M. So first thing we're doing is writing our given. Our given is that 4 is congruent to 8. Okay, our goal is to prove that L is parallel to M. Some of you on the last test missed points on the proof because you didn't have your last step being what you were trying to prove. Be careful, that should be easy give me points. You're not done until what it said you were supposed to prove is your very last step. Okay? So look at your picture, mark it, 4 and 8. What kind of angles are 4 and 8? Corresponding. So if 4 and 8 are congruent, are the lines going to be parallel? Yes, so this is just a 2-step proof. L is parallel to M, and what's the reason? Perfect. So converse of the corresponding, and I know it's a lot of writing, angles postulate. 2 steps, not hard. Here's my given. Mark your picture. What kind of angles are they? If they're congruent, then those lines are parallel. Anything you're doing, if there's a symbol we've learned, you can use it. Okay, look at the next one. Use the converse of the corresponding angles postulate and the given information, so this is all given, to show that L is parallel to M. So this one's going to be a little bit longer. So make your statements and reasons. Again, it said show, so that means I'm going to write a proof. Number 1, list your given. Measure of angle 3 equals 4x minus 80. Measure of angle 7 equals 3x minus 50. And x is equal to 30. Given. Okay, go to your picture and figure out what kind of angles are 3 and 7. 3 and 7. What kind of angles are they? Corresponding. So what should be true about them? Okay, the angles need to be congruent to each other in order for the lines to be parallel, right? So our job is to prove that these two angles are equal to each other. If we can get that they are, and I need to change that. We're not trying to get that they're equal to each other. We're trying to get that they are what? Congruent to each other. If we can show these two angles are congruent to each other, then these two lines will be parallel. So our goal is to go through the steps to show that these two angles are congruent, which is going to take a little bit of work because a proof is step by step. So what's the first thing you think we should do? Substitute. Good. So number 2 is going to be substitution property. Don't forget to put of equality. And write neatly so I can tell if you're spelling it correctly. Okay, and we're going to substitute that 30 in. So we're going to have measure of angle 3 equals 4 times 30 minus 80. And measure of angle 7 equals 3 times 30 minus 50. We're doing it for both equations, so we can do it at the same time. So what would our next step be? Simplify. Okay, so let's do that. If I simplify here, I can simplify a couple of different things, and I'm okay if you do it all at once, or you can make this 2 simplifying steps. It's up to you. But 4 times 30 is what? 120, and what's 120 minus 80? 40. So I am okay if you do all of that simplifying and just put simplify. Measure of angle 3 equals 40 degrees. Also, we're simplifying angle 7. So what's 3 times 30? Minus 50. So measure of angle 7 is equal to 40. Everybody with me so far? Okay. So we still don't have that the lines are parallel. That's our goal. So I'm going to come over here. Oops. And keep working. So step number 4. We now have that they each equal 40. What could we do next to try to get closer to the fact that they're going to eventually be congruent? Very good. Measure of angle 3 equals the measure of angle 7. What did we use to do that? Not definition. No. Not reflexive, but you're on the right track. Not symmetric. We didn't flip anything. Say it again. Transitive. Look at what we had. 3 is equal to 40. 7 is equal to 40. If two things are equal to the same thing, you can combine them. So this is like A equals B, B equals C, so A equals C. So measure of angle 3 equals 7. Anytime you have the exact same thing on one side of your equation, the other two sides are going to be equal. That's transitive property. And it's going to be transitive property of what? Okay, I'm going to abbreviate since it's my notes because I'm running out of room here. So if 3 is equal to 7, do we have that they are congruent yet? No, we need one more step for that. So now we can say angle 3 is congruent to angle 7. What says if they're equal, then they're congruent? Very good. Now that is the definition. So definition of congruence. And now if 3 and 7 are congruent, how do we know the lines are parallel? They are congruent, but I can't write over here because they're congruent. What's my reason that L's parallel to M? Yes, remember, if you have two lines parallel, over in your reason column, you have 5 options. Converse of, converse of, converse of, converse of, converse of. You have 5 options. It could be corresponding, same side interior, same side exterior, but it's always corresponding. Always converse. Sorry. So converse of, and then it would be the corresponding, I'm going to abbreviate, angles postulate. Remember, the corresponding is the postulate, everything else is a theorem. Okay, let's look at another one there. How many more do I have in your notes? Quite a bit? Okay, they're just more examples of proofs, though, if we don't get to all of them. This parallel postulate, we're going to do some constructions tomorrow that's going to come back to this postulate. But here's basically what it says. Through a point not on line L. So draw a line L on your paper, and then put a point not on line L. How many lines can I draw through point P that would be parallel to line L? Everybody agree there's only one line? That's what this postulate says. Through any point not on a line, there is exactly one line that would be parallel to the line. Kind of makes sense to me, right? Most postulates to me are kind of just common sense. So if you have a line and you have a point not on the line, how many lines can you draw through this point that would be parallel to that line? I can draw a lot of lines through the point, but how many of them would be parallel to this line? Only one. Okay. Any other line I draw is not going to be parallel. Okay. There should be 4 proofs left? Okay. 4? All right, so on this one, 4 congruent to 8. Look at the picture. What kind of angles are 4 and 8? Alternate exterior. So this says, use this information, show that the 2 lines are parallel. Here's what's been given. So to save time here, I'm not going to write all this out. But how many steps would be in this proof? 2. Okay, so this would just be a 2-step proof. Are you guys with me? Okay, we would have our given, and then what would be our reason over here for this number 2? Close converse of what angles? Alternate exterior. So it would just be 2 steps. There's no work to show here. We would just write down our given, write down what we're trying to prove, and it would just be the converse of the alternate exterior angles theorem. Okay, look at the next one. This will be the last one we'll do, and we'll finish the notes up tomorrow. This one is going to have how many steps? 2 or more? More, okay? Be careful though, let's look at 3 and 7. What kind of angles are 3 and 7? Okay, so I'm going to tell you that this will be exactly the same process as, and then I'm going to go back up, where was the long one we did? This was right here. Example 1B. Okay, so if you look back at example 1B, it'll be the exact same process. What's the only thing that's going to be different? At the bottom of the proof, why are the 2 lines going to be parallel? Okay, it'll be converse of the alternate interior Engel's theorem. That'll be the only thing that will be different. Okay? We'll look at the longer proofs that you have on the back there tomorrow. So this assignment is not due till when? Monday. There is one thing you need to fix right now, though, before you leave. Open your core math book to page 101. Core math, page 101. So if there's something we haven't went over and you're having trouble with it tonight, just don't worry about it. We'll talk about it tomorrow. Core math, page 101. As soon as you get it open, look at the proof number 5. Do you see number 5 proof? There's no picture. You can't do that proof without a picture because you have no idea what they're talking about as far as angle 1 and angle 3. So you need to draw this picture up here on the board on your paper for that proof. You should have a line P and a line Q, and they should be marked parallel. And then you should have the angles numbered 1, 2, and 3 like they are in that picture. Did I forget anybody on assignment slips?